Alright, so today we're going to work on the final kind of hand formulation, which is what we call substitution. Make sure I spell it right. Close enough for government work. And substitution is one that we do with the herbivores. And it's literally about where we're going to take and assume that the forage or roughage is the base of the diet, and we're going to substitute in energy, protein, minerals, etc. to make sure that we achieve a balanced diet for the animal. And so when we work with substitution problems, we're going to go through the following steps. Okay? And so step one is like everything else we've done, where we need to know what the animal's requirements are. And I will be giving those to you so that you're not having to look up animal requirements quite yet. We're going to be getting into that as we get into the species modules, but I will be giving you the animal requirements. The second step is knowing what feeds that we have available. And so I will give the list, and we will need to look up the feed composition data. Okay, and so that's going to be one of the key elements, is like we have been doing, is looking up feed composition data for the problems. Once we, and the things that we need to consider is what feed classes we're working with. So if you remember those IFN categories, we'll need to know if it's a roughage, energy feed, protein feed, or if it's a mineral source. And so we need to pay attention to what the classes are coming from. And so with those IFN numbers, we can tell based upon that number, and tell fairly rapidly that categories 1, 2, and 3 are going to be roughages, Category 4 is an energy feed, Category 5 is a protein, etc. So those are going to come in handy. The other thing that we need to consider is if there is a fixed ingredient. Some of the problems will have a fixed ingredient, which you need to account for from the beginning. Other problems may not. Alright, our third step is going to be to determine the forage only contribution. So how much of the nutrients are they getting from the forage only, or the forage plus the fixed ingredient, if there is a fixed ingredient in the problem. So we're going to then we're going to figure out how much is coming from the forage itself. So that's going to be the amount in pounds of dry matter times the nutrient concentration. And so we should be feeling like we're seeing this formula quite a bit in our work. And so that's going to be how we figure out the forage only contribution. The next step, step 4, is going to be figuring out if we have a deficiency or a surplus. Okay? And so that's simply going to take the supply, or that contribution that we figured out in the third step, minus the requirement from the first step. And so, and if the answer is negative, then we have a deficiency. And then we'll need to fix it. And so that's what we're going to be working to solve. And just as a rule of thumb, we have a 2% leeway, meaning plus or minus 2% of the requirement. And for the most part, that's going to be, it has to be at least within 2%. So if it's over the requirement, we're not going to worry about it. But if it's below the requirement, 2% is our magic number. And to figure that out, we're going to simply take the deficient amount divided by the requirement times 100 will give us the percent deficiency. And if it's less than 2, then you're good. If it's over 2, then you have to move to the next step. And we'll do this with some of the problems as we're working through. Next up is once we figured out what's deficient and not, and if we have a deficiency, then we need to start thinking about how to fix it. And that is going to involve calculating what we call the net gain. And the net gain is the difference in the nutrient supply on between the source feed and the supplement and the new feed on a per pound basis. So what I mean by that is if we have feed A is our main feed in the diet and it has this amount of a nutrient, we're bringing in feed B which has a higher amount of that nutrient. And so what we're looking for is this difference right here between the two. That's our net gain. We're not going to be able to maximize 100% of the new feed because some of that amount of, say, protein is already accounted in the source feed. But we want the difference between the two. Once we work through step 5, didn't think I'd use a full sheet, sorry guys. Then it's on to step 6, which is fixing the deficiency. And our formula for that is simply to take the deficiency divided by the net gain. And so our deficiency is going to be in some weight basis, whether it's pounds, grams, whatever the case may be. The net gain is essentially a concentration. So if we take this amount divided by the concentration, that's going to give us the amount of feed to substitute. Okay, so most of the time this deficiency is going to be in pounds. So it would give us pounds of feed to substitute. So that's our new feed of what we now will be putting into the ration. And then that gets us down to our last step, step 7, which is to check the new feed. And so we assume always, one of our base assumptions is that dry matter intake is constant, meaning it never changes. So if we add a feed, we must subtract from the forage. And we will walk through that where you see it with one of the examples of the 3 homework problems that you're going to have. And from here, we're going to check and measure the contributions, and we will repeat steps 4 through 7 as needed until the ration is solved. The last step, once we've solved for all nutrients, is to convert the final amounts of dry matter to as fed. That's going to now become an assumed factor that we do every single time we balance a ration, is make sure we get it to the amounts as fed. Okay, so that's kind of the basic steps that we're going to be working with. We're going to go ahead and set up to do the first problem on the homework together as a group. Alright, so we're going to work on substitution problem 1, which is the Chico State Sheep Unit has some lambs that they're wanting to finish out and sell as boxed lamb to some consumers. And so we're going to kind of work through this problem just like we would just like the steps that we mentioned previously. So step 1 is to actually get the requirements written down. And one of the keys to being successful with substitution problems is to make sure you stay organized. And so I start off by kind of building a table of all of my information, because I hate having to dig up information when I'm in the middle of a problem. And so we're going to need the following information. We're going to need to know the dry matter that the lambs need, how many net energy megacalories, or kcals actually in this problem, they're going to need, the crude protein, phosphorus, and calcium. And so when I organize actually throughout my page, I'm going to kind of keep it in these general columns so that it stays somewhat structured. And so according to the assignment, these lambs are going to be eating 3.55 pounds of dry matter each and every day. In that dry matter, they need 1,550 kcals of net energy for gain. And because we're working with sheep, they're smaller, so we're going to work with kcals and not mcals. They need 0.6 pounds of protein, 0.012 pounds of phosphorus, and 0.020 pounds of calcium. So this is all given in the problem that is presented to you. So that is step one. Now, the second step is to find the feeds available. Okay? And so the problem gives us that we're going to have Timothy hay, we're going to have sorghum as a grain source, and dried distiller's grains for protein, dicalcium phosphate, which I shorten by dical, and limestone. And in the homework, it gives you all the IFN category, or the international feed numbers, so you know which ones you have. And it gives you all the units and stuff. And so what I'm going to do is take a second and fill out this table, and I'll probably put it on high speed so that you guys can source the data as well. But I believe at this stage we kind of know where it's coming from. Okay, so we have collected all of the data. One thing that we do need to pay attention to is the book gives us, for net energy for gain, and I'm just going to make a note of this, mcals per kilogram, which we can convert to mcals per pound by dividing by 2.205. Then we need to convert that to kcals per pound, and to do so we multiply times 1,000. And so that is how I got these numbers of 360, 730, and 660. Megacalories, it's 0.36, 0.73, or 0.66. So just as an aside, that's how I got to kcals. Or you can use Google and find an online converter, whatever works. All right, so we've got steps 1 and 2. We have determined all of our data that we need, the requirements and the feeds available and what their composition is. So now we can actually proceed with setting up the problem. So step 3, according to our list, which I have my first list right here, is to determine the forage only contribution. Okay, so we are going to assume that the forage meets all the dry matter. Okay, totally meets all of the dry matter demand. So we're going to assume that all of the animal's dry matter requirement is coming from the forage. Okay, and so when we look at our list of feeds, we have Timothy hay, sorghum, dried distiller's grains, dical, and limestone. But if we pay attention to our feed classes, we know that Timothy hay is our roughage source, and that's the one we're going to be figuring out the amount. In this case, that's the amount times the nutrient concentration, which is these values here. Okay, so what we're going to do is, let me grab my calculator. And we can show you guys, make sure we kind of get this a little bit out of a glare. Okay, there, maybe not. There it is. Kind of excellent. Okay, so what we're going to do, so I'm actually going to set this up here, is we know that our lambs are eating 3.55 pounds of dry matter per day. If that dry matter is coming from Timothy hay, which is our base assumption, then they're getting 360 kcals per pound. Go ahead and finish this out. And so 355 times 360 equals 1,278 kcals. Okay? If they are getting all of their protein from Timothy hay, we're going to take that 3.55, which is the amount, times the nutrient concentration, times 0.17. And we're going to round to 2 decimal places on these. And so they're getting 0.6 pounds of protein. And I'll bring the headers down again just to kind of help you guys keep track. I generally just keep it in my columns, and that makes it easy for me to follow along. Okay, so now we need to know how much phosphorus they're getting. So they're eating 3.55 pounds of dry matter, and that Timothy hay contains 0.34% of phosphorus. So don't forget to move the decimal. So it's times 0.0034, and they're getting 0.012 pounds of phosphorus. For the minerals, I do carry 3 decimals because we're working with such small amounts. And finally for calcium, 3.55, the amount of dry matter, times this value here, the 0.66% on a decimal form, so 0.0066. 0.023 pounds. All right, so now we have figured out the contribution of forage only, and the next step 4 is, do we have a deficiency or a surplus? Okay, so we assume that dry matter intake is completely filled by the roughage, so we know that's okay. Now what we're going to do is simply take the supply, which is this value here, minus the requirement. So for example, if we take the 1278 kcals minus the 1,550 that's needed, what we see is that we have a negative 272 kcals. We have a deficiency. If we compare the protein, 0.6 minus 0.6, that is spot on. Phosphorus, let me pull down the requirement, is spot on. And the calcium is actually a little bit of excess, so that's acceptable. So right now, all we're dealing with is an energy deficiency. Now I did say that the deficiencies had to be within 2% of the requirement to know if we need to fix it or not. So to do that, if we take 272 divided by 1550 times 100, what we're going to find out that it's actually 17.5% of the deficiency. And so that's major. So that is something that we do need to fix. So that means we will go to step 5 and fix the problem. And the first part of that is net energy. And so we're going to figure out, not net energy, net gain. Okay? So when we look down our list of feeds, we know based upon our feed classes that sorghum is our energy feed. It's category 4, and it's also the highest energy source that we have. So what we want to do is figure out pound for pound what is our gain in energy by adding in sorghum? So sometimes to help visualize, if we add in sorghum, and say this is our Timothy hay, and it's got 360 kcals. Okay, so this is its net energy for gain. We're looking at subbing in the sorghum, and it's got 760 kcals. So what we want to know is this value right here in the center. That's our net gain, or what we profit basically by adding in sorghum. So to figure that out, we simply find the difference. So 760 minus 360 is 400 kcals gained. Oh, and I totally wrote my numbers down wrong. Let's re-look at that. You guys have to watch me because I do this from time to time. Okay? So actually, if you go back to the table, it's 730, not 760. My bad on that. And so what we're going to do is we find that we have 370 kcals gained in pound for pound substitutions. So the next step is to fix by finding the amount that we need. And so we're going to take our deficiency, which is the 272 kcals, and divide it by the net gain. So it's the deficiency divided by the net gain. And that's going to tell us the amount, or pounds, of sorghum to put into the diet. So I get that it's 0.735, so if we round to 2 decimals, 0.74 pounds of sorghum to meet energy needs. Okay, so now, make sure you can see all of that. Now the fun begins with substitutions, and we check it all again just like we did up here, and see if we have any more deficiencies. So I'm going to switch to another page and then I'll pick it back up in just a second. Alright, so in our problem we realized that we needed 0.74 pounds of sorghum to fix the energy needs. So we're going to add that to our amount of our dry matter. And so we know that the total dry matter has to be 3.55 pounds. That's our constant assumption that it's always going to be the same. And so what we're going to do is simply take the 3.55 minus 0.74, and that means that the lambs are eating 2.81 pounds of Timothy hay now instead of everything from Timothy hay. But what we should see is when we figure out the contribution of each feed for each nutrient, that we're now meeting the energy needs. So I'm going to go through and simply take the amount times the nutrient concentration for each feed. So for Timothy, it's going to be 2.81 times 360. And continue along the path. And do the same for sorghum. All right, so now we just total up our net energy. Whoops, 1011.6 plus 5472 equals. I'm going to round to a whole number, so 1552. So what we'll notice is that our requirement was 1550, so we have met the requirement. Excellent. Now if we take 0.58, or whoops, sorry, 0.48 plus 0.07, now we have a deficiency of negative 0.05 for protein. We'll have to see if that's something that we need to fix or not. Alright, and if we add up the phosphorus, we are still good. And we are a little bit short on calcium because if you realize sorghum really doesn't have a lot of calcium. And so we have a deficiency of 0.001. Okay, so we've got two deficiencies now, but with these we're going to work on the ones that are of major impact. So the next problem to address is crude protein. Now the first thing is I do want to know, is it within 2%? That's my question. So if I take that deficient amount divided by the requirement, let's see what we got. It shows up as 8% deficient, so we need to fix it. Okay, so we repeat the previous steps, and to fix it, we're going to need to find the net gain. So if we look at our feed sources here, we have got distiller's grains that we're going to be substituting in. And so in 1 pound of distiller's grains, it's 23% protein. We're going to get 0.23 pounds of protein from that distiller's grains. And in 1 pound of the Timothy hay, and so when we do a substitution, we always go back to the forage. You're always going to replace the forage. So 1 pound of Timothy hay has 0.17 pounds of protein. That difference is our net gain. And that net gain is 0.06. Okay, so now we have the net gain. We know that the deficiency is 0.05. And so we take that deficiency over the net gain. So deficiency over the net gain. And that's going to give us how many pounds that we need to put in, which is 0.83 pounds of distiller's grains to make up for this protein deficiency. Okay, now it's the second verse, same as the first. Time to check everything again. So now we have Timothy hay, we have sorghum, and we have now added distiller's dried grains at the amount of 0.83, 0.74. Together, all three feeds need to add up to 3.55. So if we take that 3.55 minus 0.83 minus 0.74, we see that we are getting 1.98 pounds of dry matter from each of those feeds. Now the sorghum value is not going to change, so we can just copy those numbers down. But we do need to recalculate the Timothy hay and the distiller's dried grains. So just like I did before, I am going to make sure you guys have the data in front of you too, is take these new amounts times the nutrient concentrations. So now you'll see that we've really increased the amount of calories. Because distiller's grains has so much more than the forage, we're even adding more calories. So we've met the supply there. We've fixed the protein problem. Excellent. Phosphorus needs are met. Uh-oh, looks like we're deficient. So we need to check. Do we need to fix that? So 0.006 over the requirement of 0.020 times 100. That's a 30% deficiency. Need to fix it. So here we go again to fix calcium. Alright, so we know that in 1 pound of limestone, we're going to get 34%. So from limestone, we're going to get 34 pounds of calcium. The Timothy hay is 0.066. So it's really got a tiny amount of calcium in it, pounds, from the Timothy. And so our net gain is the difference. And so what you'll see is that we're going to need a pretty small amount of limestone because it's super concentrated to fix the situation. So now we have the net gain, we can fix the problem. So we're going to take the deficiency divided by the net gain. So 0.006 divided by 13334. So we only need 0.02 pounds of limestone to fix the calcium. So now we're going to substitute that in for this Timothy hay and check it all again. Alright, so I already had this part of it done, and so if we go ahead and substitute in the limestone, that's going to change the limestone amount and the hay amount, but it still totals 3.55, and we adjust those values. And when you check the contribution of each of those ingredients, realizing that sorghum and distiller's grains stayed the same because we didn't change those amounts, what we find out now is that we have met the dry matter needs, the energy needs, protein, phosphorus, and calcium needs of those lambs. So you have now just balanced a multi-nutrient, multi-feed ration for a set of growing lambs. So the last step that we talked about was converting the final amounts to as fed. And so remember, these are all in dry matter. So to get a dry matter amount, you need a bigger number, so you simply take the pounds of dry matter divided by the dry matter percentage, which is from our table of data that we had, and you get pounds as fed. So in order for these lambs to get 3.55 pounds of dry matter, they're going to need to get about 4 pounds of as fed feed every day. And so these are going to be the final values that go into Blackboard Learn for these problems, is the final as fed amounts. Okay? Now you'll notice on the homework it asks the last little few questions are, what is the calcium to phosphorus ratio? And so that is simply where you take the amount of calcium on a dry matter basis divided by the amount of phosphorus on a dry matter basis, and we always want calcium to be greater than phosphorus. So that's why we double check this, and what we find out is that we're running about 1.5 parts of calcium for every 1 part of phosphorus, and that is acceptable. We always want it greater than 1. Generally, it should be around 2 to 1, but sometimes when you have high grain diets, it's going to be a little bit less. But as long as calcium is always more than the phosphorus, you're good to go. The second part is the percent forage in the diet. And so to figure that out, we simply take the amount of the forage out of the dry matter. I can't remember if I did this on a dry matter or as-fed basis. So let's check. Yep. Times 100 gives us 55% forage. And so that's just a quick check that as we start going into building species-specific diets, some animals are going to be a 50-50 roughage to concentrate ratio. Some animals are going to be 10% roughage, like feedlot steers. We're going to have at about 10 to 20% roughage, as opposed to dairy cattle that are at about 50% roughage, or even beef cows that are at 90+% roughage. So that's going to tell us if our diet is kind of on track for that species. And then the final question is asking what percent of their body weight. So the lambs average 90 pounds. They're eating 3.5 pounds of dry matter times 100. That's about 4% of their body weight. That's on the upper boundaries probably, because most animals are going to be anywhere from 2 to 4% of their body weight. It's kind of a good rule of thumb to make sure your answers are reasonable is, do we have an appropriate amount of their body weight? And in this case, it's on the higher end, but it's acceptable. And so that is how you do a substitution problem. There's 2 more for you to do. One does have a fixed ingredient, so you need to account for that in the beginning.